Sketch the graph of this, y equals tan half x for x between minus 2 pi and 2 pi. On the same axis, sketch the graph of 3 cos half x for minus 2 pi to 2 pi, indicating the points of intersection with the x-axis. Show that the equation of this equals 3 cos half x can be expressed in this form. Hence, solve this equation for x between minus 2 pi and 2 pi. So here's the question then. So we'll do a quick sketch of it by hand here with the axes. So we're just drawing an axis. Probably want one a bit bigger than that, I think. So let's have another go. Oh, that was okay. And between minus 2 pi and pi, wasn't it? Okay. So we want the x-axis and the y-axis. So I'll just do it here. Okay, so this is the x, 0, this is the y then. And then we just want to just get this sort of balanced out a bit. So we'll put it to there. And then we want to do it from minus 2 pi to pi, don't we? To 2 pi. So let's do minus pi, minus 2 pi. And then we go to pi on this side, and then 2 pi on this side. So the first one is tan half of x, isn't it? Here it is here. So we know it typically, characteristically, the tan function, it goes up and down like that. This would be pi over 2, and this would be minus pi over 2. But because it's x over 2, it takes twice as long, doesn't it, to get up to... So this, instead of being pi over 2, it needs to be 2... x would need to be pi to get pi over 2, wouldn't it? So it stretches it out. So it's going to, instead of going up at pi over 2, it's going to go up at pi. So it's the same curve, so to speak, but it just is stretched there. And then repeating the same pattern, it does. So this will be down here, won't it? Like so. And then this one here will come down like so. So there's that curve, and this is tan x over 2, y equals, and then we want to do the other curve. So we're going to, on the same axis, it says sketch this 3 cos half x. So the cosine function, if we look at the cosine function, cos 0 is 1, and then it goes up and down, doesn't it? This would be 1, this would be pi over 2, this would be pi. But instead of 1 it's x over 2 here, so it's stretched out again, so instead of going down at pi over 2, it will go down at pi. And it also goes up to 3, so this value here is 3, and instead of going down at pi over 2, it's going to go down at pi, isn't it? So it goes down at pi, and then back at pi, it's at minus 3. So it comes down, and like so, and that value is minus 3. And then clearly it's reflected on the other side there, and then oops, there at minus 3. Okay, I've sketched it with dashed lines because it's a digital pen. This is y equals 3 cosine half x. Okay, so there's our sketches then for those two functions that we've done. We can see there's going to be one solution here, and there's also a solution here, isn't there, in the range, and there's no solutions over here, is what we would expect. So let's have a look at the equation then, the trig equation here for part 2. So the y-axis crossing points for 3 cos, have we done that? The y-axis crossing point here, which we did. Okay, part 2 then. So part 2. So tan x over 2 is equal to sine x over 2 over cosine x over 2, and that's equal to 3 cosine x over 2. Move the cos up. So that tells us that sine x over 2 is equal to 3 lots of cos squared x over 2. Cos squared is 1 minus sine squared, so this is 3, 1 minus sine squared x over 2. So this is minus 3 sine squared. Move that over the other side to plus 3 sine squared x over 2. And then the sine x is already there. And then we've also got a 3 here from the expansion. Move that over to minus 3 equals 0. This is a quadratic in sine. And this is hopefully what they wanted us to show. Yep, that's fine. Here it is here. It's the same equation. So let's solve it then. So hopefully we can factorize. So let's try it. 3 sine x over 2. And then sine x over 2 here. Now it's got to be 3 1s. It's not going to solve it, is it? So let's just check this quadratic again. Yep, minus 3 is the quadratic. So I can't see a solution here other than we're going to need to solve using the formula. Okay, so let's try the formula then. Okay, so here sine x over 2 then is equal to, so it's a quadratic in sine x over 2, so it's minus b minus 1 plus or minus the square root of b squared is 1 squared minus 4 times a, which is 3, times c, which is minus 3, over 2 lots of a, which is 2 3s. So we end up with minus 1 plus or minus, this is 9 4s are 36 and 1 is 37 over 6. Okay, so only one solution comes out here. Sine x over 2 must equal plus root 37 minus 1 over 6, simply because the other one is bigger than 1, isn't it? Because root 37 is bigger than root 36, and that would be 1 there, and then minus another amount, and minus this bigger than 1 will be a number much bigger than 1, a little bit bigger than 1, won't it? And that's outside the range of the solutions here for sine, because it can only go up to 1 and down to minus 1. So the only root that's in the range for sine is this value here then. Okay, so sine is positive, so let's draw a circle. Don't forget we're solving between minus 2 pi less than x is less than or equal to 2 pi. So divide by 2 here, for example. Minus pi is less than or equal to x over 2 is less than or equal to pi. And this is what we're solving for here in this range. So draw a circle. Write CAST. Now sine is positive, as we said, this is a positive. Sine is positive here and here. So we've got two solutions. So x over 2 then. So we simply write, I'll get it right in a minute. We draw Markov alpha, the associated acute angle here and here. And we write sine alpha is equal to the root 37 minus 1 over 6. And that tells us what alpha is then. Shift sine. So inverse sine of this thing here, square root 37 minus 1. Now we need to bracket around that whole thing, don't we? And then we divide the whole thing by 6. So bracket there. And then divide that by 6. Close the shift sign bracket. Equals 57.900. So it's 57.9. So we can read off the angles for x over 2 then. Is equal to, just from minus pi to pi, it's these two solutions for x over 2, isn't it? So the first one is round to here, which is 57.9. And then the other one would be 180 minus the 57.9. Oops, round to here. So that's 120, 2.1. So now, if we do x, that tells us then what x is, times this answer by 2. So if we go back to our calculator, we've got the number here, times that by 2 equals 115.8. 5.8 degrees. And the other one, times it by 2. So I'm going to divide that by 2 to get back to the original. I'm going to take away 180. And that's the negative, so minus the ants will give us the 122.1, isn't it? 122.1 there, so let's put that down. And this was to 1 decimal place. And there's our... times it by 2, sorry. Times that by 2 then. Times by 2. 244.2. There we go. 244.2. And that was to 1 decimal place. Just check that again. 0.2 to 1 decimal place. Yeah, that's fine. Just one slight problem here. I've been looking through and checking all of this. The answer, of course, is in radians, and I've gone to degrees for some reason. So I better change these over to radians so that we get the answers correct in the correct format. So this alpha, really, let's just do that first. So a shift sign of that, let's start from there. Shift sign of the root 37. So let's just put that in. So it's root 37 minus 1 on top. Close the top bracket, divided by 6. And then close the shift sign bracket. And we need to be in radians, so that's number 4, equals 1.0105. So let's put that down. 1.0105 for alpha. 1.0105. So we can now read off what x over 2 is then in terms of radians. So it will be 1.0105. And the other answer will be pi minus 1.0105. Okay, so now we can work out x, just double these. And then we can put down the x values then. So let's just quickly do that. So it's 2 times 1.0105. So I'm going to times that by 2. 2.02. So it's 2.02 for the first one. And then pi, it'll be 2 pi minus 2.02. So that's in the answer. So it's 2 times pi minus the 2.02, which was still in the answer. 4.262. So it's 4.26 radians. And that was to 2 decimal places. Okay, that looks better.